IB Physics May 2025 HL Paper 1A, Question 8. Two small spheres, each of mass 10 kilograms, are 8 meters apart and connected by a rod of negligible mass. This system rotates about an axis halfway along the rod and at right angles to it. What is the moment of inertia of the system? Okay, now you may think that you need to apply the formula for the moment of inertia of a solid sphere. And that formula would be that the moment of inertia for a solid sphere is equal to 2 divided by 5 times the mass times the radius squared. But here's the thing. This formula only applies when we have a sphere that is spinning around its own center. So say a basketball that is spinning on your finger or a planet that is rotating about its axis. Well, that is not happening here. What we instead have is each sphere that is orbiting around a center point of the rod. And that would make the radius be 4 meters. So since each sphere is not spinning in place, their own spin isn't going to matter, we need to treat them as point masses. Their size is going to be considered small relative to the distance from the axis, which is 4 meters. And when we treat them as point masses, we can say that the moment of inertia is equal to the sum of the mass times the radius squared. And, well, since we have two spheres, that'll be equal to mr squared plus mr squared. Or in other words, 2mr squared. So in our case, what is this going to be? Well, the mass is 10 kilograms, and the radius is this 4 meters. Well, we can write this as 20 times 16, so we have 320 kilograms meter squared. So that means that our correct answer choice is answer choice B.